again find out the variation. So the variation is using the Leibniz rule again. Variation of W will be the variation of the right hand side, and today it will be L1 delta T1. What is L1? L1 is obtained from L by replacing T with T1. L is a function of T, Qi and Qi dots. So in this, replace T with T1. The term obtained is L1. And then variation of T1. Minus, again in L, replace T with T0. Say it's L0. And then variation of T0. Plus integration T0 alpha to T1 alpha. Then summation I from 1 to and variation of L with respect to Qi. Variation of Qi. Plus variation of L with respect to Qi dot. And then variation of Qi dot dt. Okay. Now integrating by parts, just we are proceeding in the manner that we proceeded yesterday also. We are just find out the integration of the second term, means the integration of curly L by curly Qi dot del Qi dot. So it will be integration T0 alpha to T1 alpha curly L by curly Qi dot del Qi dot dt. And it is representable as integration T0 alpha to T1 alpha curly L by curly Qi dot. Yesterday we did it. The delta Qi dot will be equal to d by dt of del Qi. And now integrating by parts, assume d by dt del Qi is the first function and curly L by curly Qi dot is the second function. Oh sorry, first and second in the sequence. Then curly L by curly Qi dot as it is, and then integration of second minus integration T0 alpha to T1 alpha derivative of first function and integration of second dt. So it is obtained. Now this curly L by curly Qi dot, it is the generalized momentum. Curly L by curly Qi dot, it will be Pi. And now upper limit minus lower limit. So it will be Pi1. Pi1 means in Pi, T is replaced with T1. Del Qi at T is equal to T1. And minus Pi naught means in Pi, T is replaced with T naught into del Qi at T is equal to T naught. Minus integration T naught alpha to T1 alpha d by dt curly L by curly Qi dot del Qi dt. Where now curly L by curly Qi dot is Pi. All of we know in when we defined the Hamiltonian coordinates, it was Pi. Now del Qi dot is d by dt of del Qi. Yesterday we obtained it. Pi lambda is the value of Pi at T is equal to T lambda alpha, for lambda is equal to 0, 1. Now let's obtain this one. The del Qi at T is equal to T lambda. It's the variation of Qi at the point T is equal to T lambda. So it will be variation of Qi with respect to alpha at T is equal to T lambda and delta alpha, for lambda is equal to 0, 1. Now what is Qi1? It is value of Qi at T1 alpha and alpha. Qi is a function of T alpha. Qi1 is value of Qi at T1. So we will have the formula del Qi1. It will be the variation of Qi with respect to T1 and then variation of T1. So it is Qi1 dot del T1 and plus partial derivative of Qi with respect to alpha into at T is equal to T1 and then variation of alpha. So from equation number 8 on the right hand side we are having the similar thing. So it is del Qi at T equal to T lambda, replace that value here. So it will be Qi1 dot delta T1 plus del Qi at T is equal to T1, which implies del Qi at T is equal to T1 will be equal to del Qi1 minus Qi1 dot del T1. Similarly, del Qi T is equal to T naught will be equal to del Qi naught minus Qi naught dot del T naught. Okay, now replace all these values on right hand side of 5. Equation number 9, 10 are obtained. This is 5. Del qi at t is equal to t1 alpha and del qi at t is equal to t naught alpha. Replace these values. After replacing these values, we obtained the value of this integration. Then replace this value in the previous equation. Here. This is the second integral of equation number 4. Then replace those values in 4. We will obtain the values as we are going to obtain now. So it will be delta W is equal to summation I from 1 to n Pi1 and then del Qi1 plus Qi1 dot delta T1 plus L1 delta T1 minus summation I from 1 to n Pi naught del Qi naught minus Qi naught dot delta T naught minus L naught delta T naught and plus value of this integration. Now all of we know that summation I from 1 to n Pi Qi dot minus L, it will be equal to H. The Hamiltonian function was defined in this way. In equation number 11, just observe the terms. First term is summation I from 1 to n Pi1 and in bracket the second term Qi1 dot delta T1 and then we are having plus L1 delta T1. So in these two terms, from the first term means from this term, the second term is taken and then L1 delta T1. Minus is common, so it will be summation I from 1 to n Pi1 delta Qi1 minus summation I from 1 to n Pi1 Qi1 dot minus L1 delta T1. And similarly, one more similar term with 1 replaced with 0 is the second summation. So say those terms are H1, we are representing that summation I from 1 to n Pi lambda Qi lambda dot minus L lambda is equal to H lambda for lambda is equal to 0, 1. Now using 13 in 11, we will have delta W will be equal to, yes, it's represented here. Summation I from 1 to n Pi delta Qi. The terms, let me reduce the size, just a second. So in equation number 11, one term is there Pi1 delta Qi1. One term is there Pi naught delta Qi naught. These two terms are remaining. Rest terms are the Hamiltonian function H delta T1 minus H naught delta T naught. Okay, so we have expressed these terms in this way. That summation I from 1 to n Pi delta Qi minus H delta T with limits 0, 1, where 1 it is represented in 15. It will be summation I from 1 to n Pi1 delta Qi1 minus H1 delta T1 minus summation I from 1 to n Pi naught delta Qi naught minus H naught delta T naught. This is the term, and plus that integral is similar. Okay, now the concept starts. That in place of n plus 1 dimensional space, we are taking 2n plus 1 dimensional space, because the initial and terminal positions are also dependent on alpha and these are also variable. So we are taking Qi naughts, Pi naughts and T naught. And now consider at the initial point we are having a curve C naught. At the final point we are having one more curve C1, and then we approached through a straight line path from this to that. Okay, so the variation of Hamilton action will be, now these are the final positions at time L, initially at 0. Also all of we know that whenever we will move through a straight line path, the Lagrange equation of motion will be satisfied. So we were at the initial curve, and when we moved up to the final curve, the Lagrange equation of motion is satisfied. So in equation number 14, when we moved from initial to final, the second term, this integral involved the Lagrange equation of motion, and so it will be satisfied, means its value will be 0. So when we move from initial to final one, we will have delta W will be equal to summation I from 1 to n pi delta qi minus h delta t at 0, 1. And now this is the variation with respect to alpha. So writing it like W prime alpha delta alpha means derivative of W with respect to alpha into delta alpha. And now integrating with respect to alpha from 0 to L, we will have on the left hand side, it will be a derivative and then its integration. So it will be WL minus W0. Why it is 0? We will discuss it. On right hand side, it will be integration 0 to L summation I from 1 to n pi delta qi minus h delta t 0 1 d alpha. Okay, now WL minus W0, it is 0. Why? Because the curve is closed. So the point for alpha is equal to 0 and for alpha is equal to L will be the similar one. If the curve is closed, then the initial and final point will be similar. So if these two are the similar points, so their difference, their values will be similar, and hence WL minus W0 is 0. And now again writing this, the term on right hand side like integration 0 to 1 summation I from 1 to n pi1 delta qi1 minus h1 delta t1 minus integration 0 to L summation I from 1 to n pi naught delta qi naught minus h naught delta t naught. Now the first term is integration for alpha from 0 to 1 means over the curve when time is t1, means on the final curve, that is c1. So it is the curve integral of this quantity summation I from 1 to n pi delta qi minus h delta t, minus the second term is integration over the curve when time is t naught, because we are representing 0. So it's the integral over the initial curve. So it will be integral over c naught summation I from 1 to n pi delta qi minus h delta t. And so from here, what we obtained, that on the final curve as well as on the initial curve, this quantity summation I from 1 to n pi delta qi minus h delta t is having the same integral value. So this term is known as the Poincare-Cartan integral invariant. That this term is invariant under closed contours when the transformation is made through the straight line paths. Okay, so this is the quantity known as Poincare-Cartan integral invariant. Okay, after that there are two remarks. I wish that you will come with, have a look on these. We will discuss it in the next lecture.